Here's an example. Colleagues of mine at Toronto. Jorge Garcia Aranda, Steve Easterbrook. Anchoring and adjustment. Here's what I'm going to do. I'm going to take approximately 50 developers, split them randomly into 3 groups, and give each group, each person, we're going to do this individually, a 2-page spec for a change I want made to a website. Please do this. Control group. Buried in the middle of a paragraph on the second page. You know, it's not blinking, because that's hard to do with paper, but it's not boldface or italic. I'd like to estimate this myself. I have no experience, so we'll wait for your calculations. That's the control group. Group A. I don't know what's going on, but I think this should take about 2 months. Group B. I don't know what's going on, but I guess this will take about 20 months. That's the only difference in treatments. Okay? What are the results? It does not matter how much experience they have with the problem domain, how much experience they have managing projects or estimating projects. It does not matter whether they do a quick back-of-the-envelope calculation or fire up one of the IBM tools, feed numbers into a complicated formula, countings, bing, 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 bing spreadsheet. Right? None of that statistically correlates with their predictions. The only thing that does, and it correlates very strongly, is that hint buried in the middle of the second page. You tell me what you think I'm expecting to hear. I've hinted at something. It's very difficult for you to decouple your subconscious from that hint. Okay? And this is called an anchoring effect, and it shows up in psychology literature and many other fields as well. If I say pick a number between, if I tell you it was a really warm day, it was about 20 degrees outside. Now pick a random number between 1 and 100. I'm going to see a clump around 20. You can repeat that experiment yourself. It happens over and over again. What this means is all of the work that has been done in software engineering on better estimation formulas. You tell me about your problem and I will grind it through this complicated formula that I got by doing correlations with all this historical data. All of that is pointless because none of it matters. What matters is the hint that the customer gives you. This is a really nice empirical result. It tells us we've been looking at the wrong problem. Okay? That's cool. I like that. I mean, disappointing for the people who've been publishing this stuff. Right? And interesting, sociologically, that some of the people who work in this field have continued to publish just ignoring this result. If I publish my 3 previous papers, the next one must be publishable. Right? So, as a footnote to this, there's a style of development called agile development, where you work in very short increments. You decide today what you're going to do for the next couple of days. You build that, you test that, you deploy it. Google does this. Google redeploys their web search software 3 times a week. They make very small changes, test them, and push that out onto the web. Because, of course, there's no download. They don't have to send you the DVD to install. You don't even have to download something to install. You're always going to their website. Okay? So the question is, instead of asking you to estimate something on a scale of months, if I ask you to do 10 estimates, one after the other, each on a scale of a couple of days, is the accumulated error the same as I get if I ask you to do one long estimate? Or are human beings intrinsically better at estimating shorter things, in which case, if I get you to work in small steps and estimate each one, the total error over a long period decreases? I could believe either answer. The test hasn't been done. But this is what good science looks like, coming back to the book Time, Love, Memory that I was talking about yesterday. All right? Every answer leads to a next interesting question. That's a healthy